This video is for lesson 6.5. Our learning target today will be to use the properties to simplify expressions. I'd like you to get ready by opening your textbook to page 473. There's a couple videos that I have listed on Moodle that are kind of fun to watch. Mr. Q does one about the properties, and the Atom Family also has a fun one. So if you want to take time, you can go and watch those two videos and then come back to this video lesson. All right, let's get started. Why don't you go ahead and try to answer these 4 questions. So pause the recording, try them, and then turn the recording back on to see if your answers match mine. All right, so Angelica and Nari are baking these cookies, and it turns out that we can use multiplication to find out how much Angelica made. She made 60 cookies, and Nari as well made 60 cookies. They just had their cookies on the pans arranged differently. And what do you notice about the answers is that they were both 60. And so what does this suggest about the order in which factors are multiplied? It tells us that the order does not matter. And we've talked about this in class many times, that we can do 5 times 2 and get 10, same as if we took 2 times 5, that still equals 10. And the same is true for addition. If I said 5 plus 2 is 7, we can also say that 2 plus 5 equals 7. These truths are not true, though, for subtraction and division. If we took 6 and divide by 2, we get 3. And if we take 2 and divide by 6, we actually get 0.33. They are not equivalent. And the same holds true for subtraction. 6 subtract 2 equals 4. But 2 subtract 6 equals -4. So the order matters a lot with division and subtraction. But in addition and multiplication, the order does not matter. So today we're going to be talking about 3 properties, math properties, that we know that's true about numbers. And this is going to help us solve expressions and equations coming up here in our algebra. So we're going to start off with the commutative property. And the commutative property, the important word here is the order. The commutative property states that 2 numbers that are added or multiplied, it doesn't matter what their order is. The product and the sum will remain the same. And that's what we demonstrated on the last slide. 7 plus 9 is 16, and 9 plus 7 is 16. So let's write that down there. And 16 is equal to 16. Same with multiplication. 4 times 6 is 24, and that is equal to 6 times 4, which is 24. And this is going to be nice in our expressions because we're going to be able to move and order the numbers correctly. So commutative sorry about that, hit the button with my hand. The commutative property, I always say, is like you're coordinating. You have to memorize it's the order that matters. And so right there we have the C, or the CO, and we have the O in order. And that's something you have to remember, that we're going to be able to switch the order of the numbers. Moving on to associative. The associative property says that when we have 3 or more numbers are grouped, that's the key word here, grouped, when they're added and multiplied does not change their product or sum. So associative is your parentheses. When you see parentheses and they're moving and grouping different sets of numbers, this is when we're using the associative property. And you have to remember your parentheses or brackets. So let's take a look at their examples. They say that 3 plus 9 plus 4. So using our order of operations, we have 3 plus 9 plus 4 is 13, and that's a total of 16. So actually, let's erase that and put it on top. 3 plus 13, and 3 plus 13 is 16. So over here we'd have 3 plus 9 is 12, plus 4, and 12 plus 4 is also 16. What's nice about the associative property is that we sometimes can put numbers together so we can do quick math or mental math with to kind of get those friendly numbers together. Over here on multiplication, you would have 8 times 35, which is kind of hard to do in your head. Might have to do some chicken scratch on the side, so I do 8 times 5 is 40, carry the 4, 24, plus 4 is 28, so it would be 280. Where it might be a little easy over here to do 40 times 7, because then I know, sorry about that, 7 times 4 is 28, and 7 times 0 is 0, so it's 280. It was a lot friendlier for me to put together. Just like over here, this side was a lot easier, doing 12 plus 4, maybe. Okay, and our last property is the identity properties. There are two of them, one for addition and one for multiplication. When we have the sum, which means add, of a number is the addend, and 0 is the addend. So 13 plus 0 equals 13. The product of a factor and 1 is that factor. So we have 7 times 1 is 7. And we've talked a lot about these properties, that any number plus 0 is that number. So we could say that with a variable, saying any number plus 0 is that number. And the identity property of multiplication also says the same thing, is that when we take this, any number that we want, and multiply by 1, we still get that number. So these properties are statements that are true for any number. The expressions 6 times 10 and 10 times 6 are equivalent expressions because they show the same, they have the same value, and that this was demonstrating the commutative property because we changed the order. We just flip-flopped the numbers. So commutative is often called the flip-flop property. So in the examples here, they would like us to determine whether the two expressions are equivalent. If so, tell which property is applied, and if not, tell why. So let's start here with this one. So noticing that I'm seeing parentheses, and that's a big clue to me that parentheses is usually about the associative property. So let's see if it holds true. So let's rewrite it down here, or just use this final illustration here. And I'm noticing that we have more than one operation to take care of, so we're going to use our order of operations. And I see parentheses. This will have to be done first, and then this will be second. And over here, this will be first, and then this one will be second. So we'll start with underlining. 5 plus 8 is 13. Rewrite it. 15 plus 13 is 28. Over here, 15 plus 5 is 20, plus 8, and that gives us 28, and they are equal. So we can say, and I'd have to say over here on this side, this would be easier math for me. I like 15 and 5, but those together, that 20 plus 8 was easier. Here I had to think about, am I carrying anything? It still was pretty simple, but I would definitely have to say I like this side better. And I did that by moving my parentheses. So this was associative. So yes, they are equivalent, and they use the associative property. And I can just abbreviate that with AP. Again, here on number 2, I'm seeing parentheses. So I'm thinking associative property, because that is dealing with parentheses. So let's take a look. And we're seeing we have more than one kind of math to do, so we're going to use our order of operations. We're going to use parentheses, and then we'll do the subtraction on the outside. And over on this side, I will do parentheses first, and then the subtraction here. So 20 minus 12 is 8. Rewrite it. Subtract 3. And 8 minus 3 is 5. And going over to the other side, 12 minus 3 is 9. Rewrite the expression. And 20 minus 9 is 11. So notice they put the do not equal sign. 5 and 11 do not equal each other. And so they are not equivalent. Because the associative property doesn't work with subtraction. Now they'd like us to determine whether the two expressions are equivalent, and if so, tell what property is applied. If not, explain why. So we start here with 34 plus 0 and 34. So I'll rewrite it. 34 plus 0 equals 34. And if we do our math, 34 plus 0 is 34, and it is equal to 34. So, yes, they are equivalent, and they're using the identity property of addition. Let's check out number 4. We have 20 divided by 5, and we want to see if it's equal to 5 divided by 20. 20 divided by 5 is 4, and 5 divided by 20 on my calculator is 25 hundredths, and they are definitely not equal to each other. No, because the commutative property does not work for division. So all the properties that we're talking about today only work with addition and multiplication. Division and subtraction are the toughies. So let's try a couple got-its here. Do these problems to find out. So we're going to use our order of operations because I'm seeing multiple, more than one, type of math. So I'm going to start off with making a plan. I do parentheses first, and then I'll do the multiplication in parentheses first, and then the outside. So 6 times 3 is 18 times 5. And it's a little harder to do in my head, but so I'll just chicken scratch it here. 8 times 5 is 40, carry the 4. 5 plus 4 is 9, so this side is 90. And I want to see if it is equal to the other side. So 5 times 6 is 30, times 3. Oh wow, this one's a lot easier to do. I like this side. I can do 3 times 3, which is 9, and 3 times 0 is 90. So they are equivalent. And looking up there, I'm seeing the parentheses, and so it's for the associative property. And it holds true, they are equivalent. Let's go over to the other side. We just have one step this time. 27 divided by 3 is 9. And 3 divided by 27 is 0.11 repeating, so it rounds off to that. And I can definitely say they are not equivalent. And it's because it had involved the division. All right, we can use these properties then to solve story problems for us too. So properties can be used to write equivalent expressions and to help us solve a problem. So here we start with number 5. In a recent season, the Kansas Jayhawks had 15 guards, 4 forwards, and 3 centers on their rosters. So we're talking basketball here. Write 2 equivalent expressions using the associative property. So associative makes me go out right away, and I think of my grouping symbols of the parentheses that can be used to find the total number of players on their rosters. So the associative property says that grouping numbers, when they are added, does not change the sum. So if we take 15 and we add together with the 4 plus the 3, I could go ahead and put the parentheses around the 15 and the 4. And that's going to be the same as, again, I'm going to keep the order the same. I can put the parentheses around the second set of numbers. Either way, it becomes out the same. Because 15 plus 4 is 19, plus 3, and that gives us 22. And 15 plus 7 is also 22. So they are equivalent, and all I did was move my grouping symbols from the first two numbers to the back two numbers. And that's using the associative property. So let's try one on our own. Brandy earned $7 babysitting, and she got $12 for cleaning out the garage. Write two equivalent expressions using the commutative property that can be used to find the total amount of money that she earned. So commutative means order. So I just had to change the order. So we could take 7 plus 12, and that would be the same as 12 plus 7. No grouping symbols, that would be associative. And we know 7 plus 12 is 19, and 12 plus 7 is also 19. So she had $19 is what she earned. And this is using the commutative property. Well, let's use our properties now to help us solve problem number 6. The area of a triangle can be found using the expression 1/2 of the base times height. So 1/2 times the base times the height. They just put it together in the algebra way, which we like. Right here, we practice this in lesson 4. The B represents the base, and the height is, H stands for height. So find the area of the triangle shown at the left. And I forgot to put the picture of the slide on here, but that slide for the kids to ride kind of looked like that. But here's the information. So we're going to start off by taking the expression 1/2, or the formula, excuse me, base times height. And we're going to say that's equal to 1/2, and the base is 15, and the height is 12. So we will replace the variables. Now, this isn't very nice. We know that 1/2 times a number is the same thing as saying divide by 2. And looking right here, 1/2 of 15, I'm going to have to deal with decimals because 15 is an odd number, can't be divided very easily. So instead, what I'd like to do, I know that 12 would be really nice. So I would like to flip-flop these or reverse the order. So I'm going to use the commutative property to reverse them and rewrite it as 1/2 of 12 times 15. So 1/2 of 12 then is 6, because it's the same as 12 divided by 2. We could do it with our fractions. 1/2 times 12, we put it over 1, and we can get 12 over 2, which is 6. Or we could do it mentally. And we're going to take 6 times 15 now, and that's a little bit easier for me to do. I can do 6 times 5 is 30, carry the 3, and 6 times 1 is 6 plus 3 is 9. So it's 90 feet squared. Now, we could have done it the other way, and we could have left it, but look at the numbers. 1/2 of 15 times 12. Well, half of 15 is 7.5 times 12. And would you like to do that in your head? 7.5 times 12. Most of us would rather avoid using decimals. So that's why we would rather not use this way. That commutative property helps us and saves us. So let's try this one. They say that Vicki earns $6 an hour while working 11 hours over the weekend. she puts 1/3 of what she earns into a savings account. Find out how much she put into the account. So we have $6. She worked 11 hours, and she puts 1/3 into that savings account. So we're going to go ahead and write it out that we're going to take, to find out how much she made over the weekend, I'd take the 11 hours and multiply that times the 6. And I also need to multiply this all by the 1/3 because I want to find out what the total amount that she made and multiply by 1/3. Well, multiplying by 1/3 again, that's the same as dividing by 3. And 3 does not go into 11 very nicely. So I'm going to go ahead and right away apply my commutative property. And I want to flip-flop these numbers because I know 3 and 6 go together a lot better. So if we rewrite it 1/3 of 6 times 11, it's a little easier because 1/3 of 6 is the same as taking and dividing by 3. We get 2 times 11. And so she put $22 into her savings account. And I was using the commutative property because I changed the order. So at this point, I'd like you to give it a try and work on your practice assignment. Good luck, and if you're having questions or having issues, make sure you come and see me, and I'll try to help you.